very quiet. We ready to go?
Yeah.
Yep.
Recording? Okay, we'll go. All right. So I did this talk about 5 years ago, not long after I joined the club, but fair few people were interested in hearing it for a second time. So I haven't updated a lot of the references, so if it's a little bit outdated, it won't affect the content, but apologies if the number of experiments has changed since then. So sorry, Brewlosophy, I'm going to talk about you in a minute. Everyone here knows me, but for those watching online, I'm Hayden Henderson. My background is process chemistry. I work by trade. I'm a power station chemist. What that is the science of minimizing corrosion and deposition by controlling the chemistry of high purity water down to the part per billion level of contaminants. Due to that, I took a slight interest in water chemistry while I was brewing. So I think I've got a reasonable understanding of the chemistry background of it. I've been doing it for the last 20 years. So this is what I've learned about water chemistry and how I think it can help your brewing. First things first is I want to explain why I think water chemistry is important and then what you can and can't do with it. So if anyone know the website Brewlosophy, they test different variables in home brewing. I guarantee just about everyone here, when they started brewing, they were told the most important thing for making good beer is fermentation temperature. You've got to control your ferment, you've got to control your ferment, you've got to control your ferment temperature. Brewlosophy tested this and found out 4 out of their 12 experiments on fermentation temperature produced a significant result in the fact that you could taste the difference in the beer. When they tested yeast pitching rate, another thing, you got to build a starter, they found 1 out of their 7 experiments on yeast pitching rate affected the final flavour of the beer. Aerating your wort, adding oxygen, something else that everyone's been told to do, 0 out of 3. Water chemistry, 7 out of 12. Doesn't sound that impressive, but still it's better than the rest. pH, adjusting pH in your water, 1 out of 5. So if you take that sample out, it is 6 out of 7 experiments they've ever done on water chemistry was significant. The only one that wasn't was when they did change the chemistry, but they kept the actual ratios of the stuff they added the same, but varied the amount. So it was effectively a significant result as well. So it will definitely change the character of your beer. First thing I'm saying is it'll change the character of your beer. It may not make it better. That's the next thing I'm saying. It will change your beer. All right. So yeah. And what I always want to say, and the first things first when you're talking about messing with your water chemistry, for almost everything you're messing with, it will produce a different beer. That does not mean it will produce a better beer, but it will change your flavour. So just remember that when in the context of this talk, with one exception, which I'll go into in a minute. In terms of starting out, the first thing you've got to do is figure out your base water profile. We are incredibly lucky in Melbourne that our water is effectively distilled water that comes out of the tap in most of the regions of Melbourne. So what I would do, what you can do is you can get it tested if you really want. Cost you a couple $100 for a one-off test out of your tap. Send it to any of the various labs that do water testing. Talk to your local craft brewery and find out where they get theirs tested. I'm sure they'll let you know it'll be $300 to get it done for a one-off test, if you want to spend the money. But what I would do, and what I did here, is start by jumping on your website of your water provider, whoever it is. It's Southeast Water, where I live. Going on the website, finding their water quality reports, checking sulfate, chloride, pH. It's all written out there. Every brewing software that you'll use to calculate your water understands what a water report looks like, so their numbers, how to put it in. So look at that and put it into your brewing software. That's your starting point. If you're a little bit anal like me, there's one very easy way to verify that. This is a conductivity meter, or it's called a total dissolved solids meter, which is conductivity, same thing, just a different front end to it, to the software. Someone wants to fill me up a glass of water on this one off the hose over there, behind Brett. I'll show you how that works. It's on, just squeeze it from the hose. What this will do, it'll tell you exactly how much in milligrams per litre, salt is dissolved in your water. So if your water report says it's approximately 30, and this comes out at approximately 30, you're pretty sure your water report's accurate. It's also a really good way of confirming if your water's changed. So before every brew, I just whack this into the water and say, oh, it's 30, yep, nothing's changed. They haven't changed the water source. Nothing to worry about here. Critical thing about this, and the reason I love this instrument, you buy this and you never ever have to calibrate it in the life of the instrument. Conductivity meters don't need calibration. We have them in our power plants that have never been calibrated in 30 years and they're still 1000% accurate. So we do check that they're accurate for safety's sake, but they never ever need calibration. So that's why this is a great instrument at home. I know there's approximately 30 ppm or milligrams per litre, same thing, of salts dissolved in this water, split between various, and this is reading at 38. So again, yeah, pretty good, guys. Probably picked up something from the hose, as this was filled from a green garden hose, which is an absolute no-no for your water. Don't use a hose. Use something else, just a tap, preferably. So that's how I check total dissolved salt in meter in your water. It takes 1 second to start a brewing. You'll buy this for $10 off Amazon. Other equipment I have is a pH meter. This is the exact opposite. I never use this basically anymore. If you're going to use a pH meter, you have to calibrate it every time you use it. I'm not saying every week, I'm not saying every month. Every single time you brew, if you want to use it, you need to calibrate it, or it is a waste of time. It is giving you nonsense. So go for a pH meter. Again, they're not expensive, $20 or $30 for a calibratable one off Amazon. But you got to calibrate it every single time you use it, or it's going to give you nonsense. So that's it. The rest of my water chemistry kit is in front of me. Micro scale, it's got some other nicknames and things like that, down to milligrams per litre. Phosphoric acid, sodium metabisulfate, calcium chloride, calcium sulfate. That's the lot. That's everything I use to adjust or check the water chemistry for my beer, as well as the online water reports. All right, so I find the most effective way to confirm what you got, online report plus a TDS. If you're not in Melbourne, you're going to have to do some other things to your water. So if you're outside of Melbourne, an RO system, a mini RO system for a couple $100 will give you pure water suitable for brewing. So I would recommend doing that as the easiest way to start with a blank slate. In Melbourne, great water. It's good to brew with. Okay, so I said changing your water chemistry will make your water different, your beer different, not necessarily better. There's one exception to that rule. If you have chlorine in your water when you brew with it, you will produce shit beer. That is something I will absolutely guarantee you. The reason being, chlorine plus yeast will produce chlorophenols, which are an awful phenolic flavour that no one enjoys in your beer. The good news is chlorine is the easiest thing to get rid of in your brewing water. Leaving it overnight will get rid of 95% of it because we have chlorine. If your water treatment company uses chloramines, that won't work. But in Melbourne, again, we use chlorine. So that'll work. Leaving it overnight will get rid of 90% of it. Boiling the water will get rid of a lot of it. Or what I do, the easiest way, is about 0.3 grams of sodium or potassium metabisulfate. This is potassium metabisulfate into your entire volume. Reacts with the chlorine instantly. Goodbye. Never have to worry about it. 0.3 grams of that. 100 gram bag's about $8. It'll last you your entire brewing career. It's also an oxygen scavenger, so it's great at the end of your brew as well when you put it in before your packaging, because it'll get rid of any oxygen in there.
How much water?
Sorry?
How much water?
A whole batch, so 30 or 40 litres.
Right.
So 0.3 grams. Again, nothing. Like, effectively a 1 cent cost, and you get rid of that chlorine. So that's the one thing I say you must do. Whatever way you do it, get rid of that chlorine. The next thing I would say is the most important way, and the thing that is most effective on flavour is your sulfate to chloride ratio. So there's two primary ions that you get in water, which are primary anions. I could go in a lot more detail, but effectively a chloride ion and a sulfate ion. The ratio of them, how much of one to the other, changes the perception of bitterness in your beer. If you have a lot of chloride and a little bit of sulfate, you get a very rich, full mouthfeel. So stouts tend to have a lot of chloride in them. So it gives you focuses on the malt. If you have a lot more sulfate to chloride, you get a crisp, bitter beer. So your IPAs, like your West Coast IPAs, tend to have a lot of sulfate. Your lagers, your Kolsch's, things like that, for that really crisp, flavour. Now, the other point on this is when you go into hazy IPAs, that was one of the big changes there. IPA is traditionally full of sulfate to emphasise the bitterness, whereas your hazy IPAs are full of chloride to emphasise that sort of rounded, smoother fruit flavour and the malt flavours rather than that bitterness. So that's one of the big differences between the two types of IPAs. As I mentioned though, if you're happy with your IPAs and you're happy with the way your beer is perceived, changing your chloride and sulfate may not make a better beer. You may have designed your recipe on what you like based on a neutral water chemistry. It'll change the perception of it. It will definitely change it. So just think about that when you're going to if you're going to do this. It's dead easy to do. Every single water calculator will do this. So I use the Brewfather one. You've also, Greyfather's got one. Brew and Water's a famous spreadsheet. Beersmith's got one. There's a million others online, dead easy. I use two things. Calcium sulfate, calcium chloride. So you enter it. If I want a sulfate type beer, it'll be about 10 grams of this and about 4 grams of the calcium chloride, and vice versa. And then you have a neutral. I tend to use a neutral profile, like 50-50 for my Belgians and things like, and my sours and things like that. So again, your water profile will do that. That'll change your perception of the bitterness and is the strongest impact on the flavour of your beer. Really nice in soda water as well. Like if you're just throwing soda water on tap, really a lot of sulfate in your water will give you a really crisp, punchy soda water. So that's just a little tip there. So the other thing I would always mention on this is don't aim for a city's profile. Don't think, I like stout, so I'm going to match Dublin's water profile. Guinness have long been treating their water before it goes anywhere near a mash tun. So, do it based on the chloride to sulfate ratio. So either aim for a multi one where it's chloride, neutral where they're even chloride and sulfate, and bitter where you've got more sulfate than chloride. Simple as that. A lot of beer styles evolved because of their water profile, because of their sulfate chloride ratio. So that's really sulfate heavy water in Burton on Trent, where IPA developed, and again a more multi-profile in Dublin. But that's long gone now. We understand why that happened. Now focus on why that happened if you're going to do it. The next parameter that a lot of people adjust is pH, and I do adjust it sometimes, but very rarely. This is not going to, unless you're putting a ton of acid into your beer to make a sour beer by just adding acid. Changing your pH in a minimal amount is not going to change the flavour of the beer. That's been shown pretty conclusively. What it might do is give you a more repeatable process and improve the efficiency and things like that in your beer. So just think about how you want, if you want to go down that route. I do it just, again, for consistency in my beer. To bring the pH down, I use phosphoric acid. Again, any of the software calculators online will do this for you. You'll put in your ingredients plus your chloride and sulfate, and it'll tell you how much acid to add. There's 98% phosphoric there. It does give you...
sanitizer?
It's the same stuff basically, but it's higher cost. It just hasn't got the surfactant in it that sanitizer does. But it's effective. Really good way to measure it out is like a children's syringe for giving medicine. Doesn't always make you popular if you use all of them up, but that is a really good way to measure it out. And again, any of the softwares will tell you how much to put in there. Put in your malts into your thing, just click on the water chemistry section, it'll immediately show you how much to do. The other thing is, what it actually does is it moderates the enzyme activity and the conversion of starch to sugar, so that the conversion of starch to sugar enzymes are highest at a pH of 5.2. So that's why you hear about aiming for a pH of 5.2. The other thing is dark malts will bring your pH down for you. You never have to add acid if you're adding a lot of dark malts, so your stouts and things like that just don't need it. They may need to be brought up, but that's again rare. The only other thing I'd say on that, it's not an essential messing with your pH. It's not something you need to do on a brew by brew basis. But if you are really anal about process, or if you love the process side of brewing, good on you. That's something you can play with as well. The only thing I'd say is don't use acid malt. It's not predictable. It's not consistent. It's a pain. You can buy acid for nothing at a brew shop, like a couple of bucks, and you'll get a bottle that'll last you for the rest of your brewing life. So I wouldn't mess with acid malt. I'd just use an acid. In terms of how to do it, how to adjust, I'd use an online calculator. There are heaps available. But every good brewing software has an awesome one built in. I think most of them are based on the Brewin, BAU apostrophe in water calculator, which is available. There's a free version and a pay version. It's fantastic. So you can add in all your malts there. But like again, Brewfather, Grainfather, Beersmith have also got things that are very, very similar to that built into their software now. So and they'll tell you what your water's going to come out like with what you do. So get on that, play with that. If you want to do it, if you need help, give me a call. I'm always happy to answer questions on this. Best way to ask me questions on water is on our Facebook group. I will check them and just tag me in them, because it's good that everyone gets the opportunity to see the answers and learn from it, so I don't have to answer the same question 40 times. And it's good for the club as well. So if you have any real questions on that, feel free to give me a call if you don't want to put it on Facebook, but the Facebook group's a really good place for that. And yeah, as I say, the 2 takeaways is get rid of your chlorine, most importantly, and secondly, changing your water chemistry will make your beer different. It may not necessarily make your beer better. So just understand what you want to get out of it by changing your water chemistry. In terms of the things to do, get rid of your chlorine. I keep saying this. Consider whether you want to change your beer profile with sulfate to chlorite ratio. That will have the biggest impact. And consider whether playing with pH is right for you in your process. Things not to do: don't try and mimic a water profile from another city. You're not going to successfully achieve some historic water profile, and it's not going to produce better beer. Understand what you're changing and why you're changing it. Don't assume changing your water will make better beer. It certainly won't turn a bad beer into a good beer. Don't spend a fortune on equipment. I've probably got $40 worth of stuff in front of me here, and it's more than effective. And don't use a pH meter without calibrating it. Otherwise, yeah, water's 95% of beer. It has a massive impact on the final product. So yeah, enjoy playing with it. And if you have any questions, fire away now.
Buffer. 5.2 buffer.
Yeah, look, that'll work effectively. That'll maintain your pH at 5.2. Adding a buffer.
pH meter, did
Yeah. I mean, you can use that as designed. I don't really play with the pH a lot myself. In general, I'll just bring it down if I have a really light beer like a Kolsch or a Berliner or something like that, or something in a kettle sour. So I just use acid, but buffers will work effectively at maintaining your pH. Yeah, absolutely.
You treat both your mash and your sporge water?
I treat it all at once. So I heat my full volume together, and I just treat that as the total water I'm using. That's the way I do it. You can do them separately. You can just do your mash if you really want, because again, the chemicals will carry across and knock it out. But I treat the whole lot together when I'm heating it up.
How anal are you on 5.2 grams versus?
Great question. I think that is the biggest waste of time in your life. The reason being, I will guarantee you this thing is somewhere around 10% water already, because it's not been dried out in an oven and held in a vacuum sealed container with silica gel. If you were in a lab, a commercial lab, any reagent you use and want to measure accurately will be dried out in an oven and then maintained in it with desiccant in the container to ensure that water's gone. So you can spend your whole life getting down to your 3rd decimal place, but you don't know your water concentration, so you're not going to get close to it like that anal. So I wouldn't worry about being anal down to multiple decimal places.
So you don't pay any attention to magnesium?
Look, yeah, as itself, you can, like it's certainly the classic birdnosing water adding magnesium sulfate. I haven't noticed any difference when I've played with magnesium, and I've not seen any experiments that do, so I focus on the sulfate to chloride. It's the counter ion, so you can use magnesium sulfate instead of calcium sulfate if you want. Maybe there's a small effect on the yeast, but I don't think it's a major difference.
And do you weigh it dry? I know some people that make a soluble solution.
I've seen people. No, I just weigh it dry and throw it all in.
We've also done a bit of an philosophy style experiment. Got water
Do
chemistry.
you want to stop the camera? Or?
Yeah. Yeah, probably. Sorry, I didn't interrupt, but I poured out